So we're going to be discussing anatomy and physiology. We're going to start off with the basics and end up with like we stop at the stop at the nervous system. This will be 12 weeks long, obviously. And let's go over some of the, if you have a question, raise your hand. Okay, and I will get to you so we don't all go in at once. But let's go over the syllabus a little bit. So this is BIOL40. It's online. It's synchronous. It starts Monday at 6:30, and it ends at 9:20. This is the Zoom link right here. I will give you the password and the code to get in, so you don't have to come in as a guest. Okay. Obviously we don't have. I'm not a. There's no science building, but this is my email. Office hours will be from Monday 5:20 to 6:20, and Tuesdays for lab 5:20 to 6:20. This is Monday one is for lecture. This is for my lab. Okay, this is the Zoom link for the office hours only. Right here. Okay, like we said, you're in BIOL40. It is the um, first half of a year-long anatomy and physiology course. Anybody else is in? All right. It is biology for non-major students. No prerequisites for this course, although a background in high school biology is assumed. Okay, so the sequence is BIO40 and then 41 designed for people who are wishing to pursue a career in physical education, dietetics, nursing, what have you. Okay, these are your requirements. You need to have these. Reliable internet service is key. All right. The idea that my internet is out, I can't do anything, honestly, doesn't fly. I'm sorry, it just won't. So try to get your, unless it's like a system-wide issue. Okay, so it's a system, if there's a system-wide issue, that's a different story. But for the most part, like if you have a storm or a hurricane, but for the most part, you have to show proof that something happened. Um, the book is the fourth edition book. Only the fourth edition book. Okay, McGraw-Hill Connect, only the fourth edition. If you click on this, it takes you to the link. See, look, there it is. It's this kid with a he's blowing a bubble or something. But that's what it is. If you don't see me, just say something.
Professor, just so you know, no one sees a textbook. It's only a DS
Yeah,
syllabus.
I figured it stopped. It stopped sharing. Hold on. Let's try that again. No, I won't show it. Oh, I know what I'll do. Hold on. This is the one. That's the link that comes up. You guys see it now?
Yes.
Yes. See you, Professor.
So let's share it. Right. We'll be using, most likely, we're going to use the QC Zoom platforms for this course. I'll post assignments in the Q&E Blackboard like you've seen already. Videos, if there's anything that I want you to watch, certain videos I'll put up for you. You obviously need your credentials to get into Q&E, log in there. Okay. If there's for any reason you need anything, you can contact me or one of the other teaching professors, Ms. Mueller, Mr. Salinas, or Ms. Das. Okay, so those are the lab instructors. You can always email them and they'll get back to you as soon as you can. So you have the whole list here. All right, so the course objectives right there. Hold on one second while we figure out who's talking. And we got to admit 4 more people. One second.
Professor, there should be an option to like mute everyone since you're the host.
Yeah, I know, but
Oh, okay.
We got 200 people, right? So I'm going through, got to mute everybody. Whoever just came in, if I didn't catch you, mute yourself. I think I just muted everybody. Yeah, it is a little hectic, but you know, the first day, we'll get to it. I expect you guys to be on time. So again, in this course, we're going to look at anatomy and physiology. The physiology part is what we're mainly focused on when it comes to in lecture. The anatomy part is what we're mainly focused on when it comes to in lab. However, that being said, um, you will see that both of these systems intertwine with each other. So if you can see it and understand that they both go hand in hand, it makes understanding both courses, it makes it understand a little bit easier. You're going to develop a vocabulary appropriate with the appropriate terminology to effectively describe or communicate information related to the anatomy and physiology. All right, so that's you're going to be doing all that. We're going to identify and describe the microscopic and the macroscopic anatomy of the structures involved uh, in the system. We'll describe normal physiological functions and organ systems, what have you. The relationship between the body and the systems. Okay, we'll do some lab procedures. Obviously, the lectures will focus, like we said, on physiology. But like I said here, to do well, it is important to attend your lectures. Okay, and attend means even though you're signed on, I want you to actively listen. I may call on you this week. We don't have any poll questions, but next week there will be poll questions, and it's going to keep you on your toes. So you're gonna have to answer questions. If I see I'm going to get 20 or 30 people out of 200, well, you know, we're gonna have to discuss what's gonna happen. There are gonna be options and see what we're gonna do to make that better in regards to your receptiveness. All right. Another thing, lab, you have to do well also. It's mandatory lab. You have to be there at every single lab. If there's a reason you have to make up something, um, tell your professor, get in contact with them. Okay. Make sure that they know that you're able to make up that lab as well. Okay. So, patient, sorry, it's been a long day. I'm also a physician, so I have my own office and I work at two hospitals at the same time. But that's why I said patients. But students who come to lecture, come to lab, tend to do better. Ask questions. Come to office hours. That's what we're there for. Again, I'm going to say this again. Come to office hours. You have questions. Come. That's why we're there. Okay, like lab will focus on microscopic and macroscopic anatomy, right? You cannot course hop, like we said. You can stay in the lab. If you miss one, you need to get permission from your from the instructor that you're in, and you have to notify the other instructor you're coming in. Okay, so we're going to have exams. We have 3 lecture exams and 4 lab exams. We're going to go over some of the. We're going to go over um, real quick how you the layout, what's going to happen. You cannot miss and make up more than 1 exam between lab and lecture. Okay, makeup exams may be given if you have missed an exam due to an unusual circumstance, and you have to provide proof of the extenuating circumstance. So you have everything in there. Great assessment. Great assessment.
Half a mile.
So the
Professor,
great, yeah.
is the lecture exams multiple choice or short answer questions?
For the most part, the lecture exams are going to be multiple choice, fill in the blank, true and false. There's no real short answer because, well, if you look how many people are in the class,
Yeah.
That's
I
going to be
understand.
and I'm already having problems seeing. So
All right, thank you.
will have connect assignments, lecture participation. That's 10%. If you see on connect, I put something. They're called quizzes. Calm down. They're just assignments, but you must do them in a timely manner. Okay. None of the connect assignments will be. Uh, once the due date is done, it's done. It's not going to come back up. Ask me, don't ask me. You can bribe me. No, it doesn't make a difference. None of it is going to happen. You're not getting that back up. Okay. So once the due date is gone, it's finished. So please make sure you use your time well. Do what you have to do in your connect. I'll be back to the connect for a minute. Lecture exams are 45% of the total grade. There will be 3 lecture exams to test your knowledge of physiology, and the lab is 45%. So altogether, you're looking at 100%. And so inside the lab, there's 9% is participation. Okay, here are the breakdowns that you have of the lab exams. Obviously, don't cheat. You all know that, right? And if there are accommodations or you have disabilities for whatever reason that's going on, please make me aware and also make your lab instructor aware. Okay. And for anyone who needs extra time on test, you need to present proof of the extra time from, I think it was not freeze hall, or maybe it was that you need proof. So you have to hand in the extra time disabilities form. I think uh, people know those people who need it know what I'm talking about. Hold on, Rena, you have a question?
Professor, can you go over the connect because I sign in, but I don't see no difference between the lab and the lecture assignments. So
Okay.
yeah.
So all right, and then okay, and Janelle, do you have a question?
Yeah, it was regarding the reasonable accommodations. I remember writing an email to you. I don't know if you
Yeah.
received it
So
or
I think I have something for you. Are you in my
okay.
lab?
I am in Miss Moyler's lab.
Ms.
So
Mueller.
I have to,
Okay, I'm gonna
yeah.
speak with. I think I have it. So
Okay.
I think I saw something. I think a week ago. So
Oh,
I'll look
perfect.
for it again. Okay,
Okay, do I have
just do me a
to?
favor. Just send me a chat to me right now with your name and what it was.
Okay, thank you very much.
Sure. All right. So when it gets to connect, let me go to here. When it goes to connect, there are different. Where's the lecture part? Hold on. There it is. So if you're looking at connect, you see here where you have content, all your labs, first of all, week 1, week 2, I want you to go through here to do your connect assignments because these are connected straight to connect. So it's Blackboard deployed. So when you do the assignments from here and you complete them, it gives you the score. It automatically puts the score into that area.
Professor, I'm sorry. Should those things be up already or not? Because I don't see anything on my lab section.
So it's not in lab. These are in lecture.
Oh, those are in
The
lecture.
reason
Okay,
I put
sorry.
it in- right. The reason I put them in lecture is because they're there under the lab content. So if you see a content here, this is lecture. See, it says lecture.
Oh, okay, I got it now. Yeah, thank you.
Lab and then lecture. This is the lecture for our. This is an invalid file. I don't know what the hell this was. So this is the lecture slide. Going back. You'll
Listen,
see-
I'm sorry to
Yeah.
break you up. I already did the labs through the Connect. I didn't go through Blackboard. I went straight through the website. So what do I
You
do now?
should go through the Blackboard.
I know, but I already finished lab 1.
Okay,
I did
who's your instructor?
my instructor Salinas.
Okay.
Professor
So you
Salinas.
already did it. So we're gonna I gotta see if that was done. But from this point on, you're going through here.
Okay, no problem. I just didn't know that because nobody mentioned that.
I know it was well. You were the first Wednesday class where, well, it's Queens College. Things are the way they work doesn't make sense. But
Yeah.
anyway, so all labs must log in through here. Okay, this is lecture. This is lecture connect. These are all the labs for the lecture connect series, week 1 A and P, right there. Okay, now being the fact that these next 2-3 weeks are a little weird, I'm giving you guys, because of all the holidays and the mishmash and everything else, I'm giving everybody a couple weeks to finish labs 1 and 2. After that, it's going to go on to a regular weekly schedule. Okay. So anybody else in the way? Are you guys coming late? You guys, whoever just came in needs to come in on time at 6:30. Rebecca, what's your question?
Hi, sorry, but I missed my first lab. I was the Wednesday class with Salinas,
Okay.
and she told me to email somebody that does the Tuesday, and I sent you an email.
So you have to come in for the Tuesday one.
Mhm.
Well, that's tomorrow. Okay. So you're okay. So send me a text message with your name and what you need.
All right, thank you.
Okay. No, the quiz that's up on Connect is, well, that's part of the assignment grades. As part of the participation. So when you're done here, when you're done your studying, okay, remember, study it first, then go forward. Okay. Study it first, then go forward. Sorry.
Professor,
Yep.
I registered for the Connect course and I used the links that Selena's provided and I completed lab 1 and the lecture assignments. I don't understand why it's telling me to complete it again when I clicked the links that you had posted in lab.
Because the link probably was the link that you use to the lab is the one that's linked to the Blackboard. So that's the one that needs to be used. So I think afterwards, after
Blackboard graded the assignments though. My lab 1 Blackboard graded
Okay.
it and the assignments, so I don't have to
we
redo it,
just
right?
hold on to those and then we'll take a look at it probably towards the end of the semester. I'll get the numbers from you and I'll put it in.
All right, sounds good. Thank you.
Who is add me to? Add you to what? Who's Petrol Baird? Why is saying oh, you're adding for this thing. You're talking
So
about
Professor, the quiz are not graded. It's just for participation, right? If I'm correct.
it does grade it. So
So will it matter to my
I
final grade?
want you to do it. I want you to get a good grade on it. That's what it makes. Not just do it and yes, you get a 0 and you think you're getting participation. It doesn't work that way.
Okay, got it. Thank you.
Okay.
Professor, dining room.
Last question. I'm gonna get moving.
So we have labs and lecture, and then we have labs and lab, right?
Like, oh yeah, right.
No. Again,
Oh, okay.
in order to get
Actually, I was
credit
gonna
on
say,
Blackboard and have it
table,
graded, whoever is on, please mute yourself now.
I want that where
There we go. Whoever is
able to click. Can you guys mute yourselves?
I just shut them off. Whoever, when you go to Blackboard, in the lecture part, there's this part that says in content, there's lab. You will do the lab assignments through those links. That link will give you a grade on Blackboard. If you do it any other way, it's not going to work. Maria.
Yes, Professor, I'm a little lost. I know you were asking people about instructor. How do I know my instructor?
You know your instructor. Well, what day are you going to class?
Tuesday.
What, your lab is Tuesday night?
Mm-hmm.
So when you're talking to your instructor?
Tomorrow?
Yes. And
That's it.
I put the link up already. So it's up in your lab section.
Okay, all right then, appreciate it, thank you.
All right, last one, Leora, last question.
Hi, so I just wanted to ask, is the Connect for Lab different for the lecture for from the Connect for lecture? Like do like
Yes,
the
they're different assignments. So Lab Connect you do during lab. The lecture one you can do on your own time.
okay, thank you.
All right, let's get moving.
Can I just ask real quick? Connect is through Blackboard.
They're
Just to
both
clarify.
through Blackboard, or Connect
Okay.
must be done through Blackboard. Do
All
not
right.
do it any other way, or you do not get credit on Blackboard.
Okay, got it. Thank you.
All right. Yeah. So you guys see this?
Yes.
Very good. So the science of anatomy and physiology. Anatomy studies the form, the structure of the body. Actually, turn it to this. There we go. Okay, it's the form, the structure. Physiology is how it works, right? Physics is the study of how things work, and ology, the biology or the physics of biology. Form and function, I said, are inseparable. You guys have to stop coming in late. Okay, basis for understanding human health and performance. It's studied using the scientific method, observations, signs and symptoms, developing a hypothesis, right? A hypothesis is basically making up a what do you call an educated guess. Okay, you experiment on and test the hypothesis to collect data. The conclusion is based on the collected data that you have. So anatomy, let me just 1 second. Anatomy, you have two parts. You have microscopic anatomy, which deals with cytology with cells, and histology with tissues, and you have gross anatomy. Gross anatomy is macroscopic, right? You can see it in different ways. You can see systemic anatomy, where you go through systems, where you go through the cardiovascular, you go through the integumentary system, you go through the nervous system. That's what we're going to do. Then you have the regional anatomy. So regional anatomy is usually done in medical school, right? So you take the region of the neck, for instance. So you see my neck, and you'll see like in this area um, you'll have the veins, the arteries, the muscles in that area. In the head, you have the veins, the arteries, the muscles, the brain, the tissue, what have you. So you go head region, neck region, thorax, abdomen, pelvis, so on and so forth. You could have surface anatomy, which we're going to talk about, different angles, different arteries, what have you. Comparative anatomy, we really don't do. And embryological and fetal development, which we're not going to have either. So you also have different branches. You have pathological anatomy. Okay, so what happens when there are changes? Okay, pathological changes in the body. For instance, what happens to someone pathologically with their lungs when they smoke? What happens to someone's heart when they have a blocked artery and get a heart attack? And you can have radiographic ones. You could have X-ray. You can have an X-ray of a hand, for instance, or you could have a CAT scan of someone's brain, for instance. So those are radiographic kind of procedures. So this is cytology. Okay, you're studying cells. Anybody know what this is a slide of? Raise your hand. I can't see anybody.
White blood cell.
Yep, red blood cells, white blood cells. So this is a cytology, right? So then this is the next one would be, what would this be? What does this look like?
Platelets.
What is it?
Platelets.
Cheapniks?
No, platelets.
Nope. Janelle.
Sickle cell.
It's sickle cell.
Sickle cells, right? This is sickle cell. This is sickle cell. This is a pathological sickle, right? Sickle cell you find mainly in African Americans. They find why it's a way to fight off what disease? You know,
Malaria.
correct, malaria. Okay, the malaria, the trypanosomes can't live in here, so they die. Sickle cells. But the problem ends up with sickle cells. Too much of these ends up clogging arteries and veins and be very painful. So how do we study anatomy? First, we inspect, you visualize, you palpate. Palpate means basically to touch or feel. You auscultate means to hear. You percuss. Percussing would kind of be doing this. Okay. Dissections. You could do comparative dissections. You can compare, for instance, we don't do it, a dogfish to a cat, or we do cadaver ones. Cadaver dissections. Again, you're not going to do, but it's done in med school, and I've seen my fair share of them. They're very interesting. Okay, a lot of the dissections have common ancestry and structural similarities, and you have exploratory surgery, which a lot of doctors, if there's something wrong, someone says, "Well, I'm going to do what's called an exploratory laparotomy." You go in inside to take a look at what's going on. Microscopy, you use a microscope, and we have also medical imaging techniques and or radiology. Ultrasound. Who here has had an ultrasound of their body part? Usually it's a soft tissue. Okay, so I get people, you don't have to tell me what, but everybody looks like they had something, right? You do ultrasound, women will do ultrasounds of they'll do it when if they first of all they can do an X-ray of, they do a mammogram, which is an X-ray, and if need be, the mammogram shows a spot, they can do a breast ultrasound. Men can do, if they lift something heavy, especially the younger, can twist the testicle. They can do a testicular ultrasound. You could do an ultrasound of your thyroid. You could do an ultrasound of almost any soft tissue that's imagined. Your gallbladder is another. X-rays obviously use high energy light to get an image, right? We all know what X-rays are. When you break a foot, a hand, or anything, you get an X-ray, and it basically shows the bone. All the soft tissue is black. The bone is different. Computed tomography or CT or a CAT scan are X-rays taken from different angles, okay? And they produce a 3D image of the internal organs. One CAT scan is believed to have as many as 200 X-rays. When you do a CAT scan, you're getting about 200 X-rays. A PET scan uses compounds to trace, or radioactive compounds to trace metabolites in the cell. The MRI uses high energy magnets or radio waves to produce a detailed image of the organ. And it also works good for soft tissue. It just takes a longer time. It just takes a longer time for that tissue to, for that image to come about.
Professor?
Yeah.
So one question. The city, this city,
yeah.
Yeah, the city can see just angles of the, you
No,
know,
the CT
different.
can see, it takes different, it's basically several X-rays done in layers, and the computer puts the puzzle pieces together, and it can show you your entire, it'll show you everything. It can show you the inside, it'll show you your intestines, your kidneys, the liver, your this, everything.
Okay.
But it just, it can show you all that stuff.
Okay.
Share this with you guys. So here it is.
study of the parts and structures of the human body. We will go back in time for a few thousand years to find the inception of anatomy. First, what are anatomy and physiology? What is the difference? Anatomy is the study of the structure of the body. Physiology, the study of how the body works. So now we know the difference. Anatomy is about structure, and physiology is about function. Anatomy is the oldest scientific discipline of medicine. The term anatomy is originated from a Greek word that means to cut up. The history of anatomy dates back over 3,000 years. It continues to evolve until the present day. Anatomists of the period studied anatomy by dissecting animals, particularly pigs and monkeys. The first documented scientific dissection on the human body is dated as early as the 3rd century BC in Alexandria. According to the ancient Chinese, everything in the universe was dependent on the balance of the two opposing cosmic principles of yin and yang. That points at the pairs of equal opposites attract and complement each other. This belief provided the rationale for the practice of acupuncture. The Greek philosophy dominated medical thought for over 2,000 years. Hippocrates, 460 to 377 BC, is considered the father of medicine because of his school's sound principles of medical practice. Erasistratus, another Greek anatomist, was more interested in the physiology of the body. He is referred to as the father of physiology. He thought that the heart's left ventricle was filled with vital air spirit that came in from the lungs and that the arteries transported this air. In addition to a great library, there was also a school of medicine in Alexandria. The study of anatomy flourished because of the acceptance of dissections of human cadavers. Herophilus was a Greek physician who later moved to Alexandria, contributing to understanding the nervous system. Roman civilization founded in 800 BC. The majority of the scientific documents from the Roman Empire are collections of material gained from Greek and Egyptian anatomists. New anatomical information was scarce. Roman doctors were not permitted to dissect human bodies unless to determine the cause of death. Their knowledge of human anatomy was restricted. The Middle Ages were the period that witnessed the collapse of the Roman Empire. Limited progress followed that in anatomy. Meanwhile, the Islamic world was flourishing. The surviving scientific Western scholarship from the ruin was transferred to the Arab countries. Anatomy evolved in the 17th and 18th centuries. That period is known as the Renaissance. That time anatomy became a more popular topic among scientists. During this period, the circulation of blood was discovered by William Harvey. Thanks to Vesalius, who is regarded as the father of human anatomy, he had a tremendous impact on the advancement of human anatomy. Significant scientific contributions happened during the 19th century. The cell theory was the most significant breakthrough because it explained that the body's function was directly related to cellular function. In the 20th century, the science of anatomy became more specialized, and research became more detailed and complex. During the 20th century, life expectancy at birth increased from 48 to 74 years for men, and from 51 to almost 80 years for women. The technology grew so fast that imaging anatomy progressed with CT scan, MRIs, ultrasound, PET scans machines. Congratulations for making it alive to the 21st century. How are we now contributing to the field of anatomy? In 2003, scientists realized a sequencing of the human genome or genetic blueprint that points out the mutations leading to cancer. And now, using stem cells, scientists can grow human organs, which they can use for studies, with a promising potential to use in the future for transplants. We cannot end a topic about the history of anatomy without mentioning some names that left a significant impact through history. Menes, Egyptian, wrote what is thought to be the first manual on anatomy about 3400 BC. Galen, a Greek anatomist, was probably the most influential medical writer of all time. He established principles that went unchallenged for 1,500 years. Leonardo da Vinci created anatomical drawings of unprecedented quality based on human cadaver dissection. Schleiden and Schwann formulated the cell theory in 1839, which was considered one of the most notable breakthroughs in medicine. Wilhelm Conrad Röntgen, a German physicist, discovered X-rays accidentally in 1895, which now remain a cornerstone of modern medicine. We now have come to an end.
I'm sorry. But that was a little sharing of quick anatomy. All right, anatomical variations. No two humans are exactly alike. 70% share the most common structure. There are people, 30% have an anatomical variant, and not all variations are harmless. So if you look at here, you have two kidneys on one side, one on each side, right? And in this case, that's normal. You have a pelvic kidney in this sense, it's kind of lower down. It's still not normal, but it still works. And you have a horseshoe kidney, which is not good, and this is considered life-threatening. Okay, so variations in organ locations, it could be situs means site. So situs soleus is the predominant layout of the body, like typical, the normal layout. Situs inversus, it means everything is basically reversed. Okay, and then you have situs perversus is in manner contrary to typical, like a single organ is affected, meaning like dextrocardia. What does dextro mean? Anyone know what dextro means? Someone raise their hand. Dextro. Anyone? Someone? I can't see these things.
Left,
Oh, other way.
right?
Correct. Cardia. What does cardia mean? Anyone take a guess? Cardia. Cardiac. Yes, Jana.
It's and it's heart, isn't it?
Heart. Oh,
Cool.
dextrocardia means your heart is on the right side. Okay. So you can have, for instance, you can have one kidney, you can have two spleens. You miss sometimes a person is missing muscle in the leg. Sometimes instead of having 5 lumbar vertebrae, you have 4 lumbar vertebrae. So all these different things can happen. And it's very rare to have someone who has situs. Situs inversus meaning the entire system, head to toe organs, internal organs are, are flipped, meaning the heart is not here, it's on the right. The stomach is not here, it's flipped to the right. So everything is flipped the other way around. All right. So we talked about that. Right. So like I said, this is what situs in. This is normal here, and this is situs inverse. See that? So that's about anatomy. Now physiology. Physiology focus on the molecular or cellular level. You can have a reductionist approach, where you kind of break everything down to its all minimalist parts, or you have a holistic approach where you take everything and put it together in order to make an organ or an organ system work. So the theory that a large complex system such as the human body can be understood by studying its simpler components is called reductionism. So you'll take this the human body and break it into its smaller little pieces to figure out how it works. Okay, holism is the complementary theory that there are emergent properties of the whole organism that cannot be predicted from the properties of the separate parts. Right? Like human beings are more than the sum of its parts. So here are car parts. You know what each of the car parts does, okay? But it by themselves alone. So that's a reductionist idea. By themselves alone, you know what each part does for the car. But when you put them together, they give you a working car. In the idea of human beings are more than the sum of their parts, you can think of it as looking at a nerve cell in the brain. You know all its parts and everything, but you don't know what thought may be coming out of it. But when you take all those nerve cells, bunch them together, make them to a brain, then the person can make, or the human being can make decisions, whether good, bad, right, wrong, what have you. Okay. Other disciplines that are part of the particular body system: respiratory physiology, molecular, cardiovascular, respiratory is lung, muscular is muscle, cardiovascular is heart and veins, neurophysiology is the brain, and pathophysiology is the relationship between the function of an organ system and the disease or injury of the system. Okay, you have reproductive physiology. So, does anybody know the relationship between anatomy and physiology? They want to take it. What is it? Anyone know the relationship?
Can I?
Yeah. Go ahead. What's your guess?
So anatomy is the placements, like the physical placements within the body, where they are in relation to one another. And then physiology is how they're interacting with one another and what they do.
Correct. So anatomy is the actual structure, whereas physiology is the actual function. And if the anatomical structure changes, then there can be physiological consequences. A good example would be a heart. If the heart, if the heart goes through what is known as heart failure, congestive heart failure, the heart will get enlarged, and it can no longer properly uh, continue its physiological function. Yes, George.
Sorry, that was an accident.
Oh, again, there are physiological variations, just like we have anatomic variations, blood pressure, heart rate, hormones, blood composition, sex, age, diet, weight, physical activity, certain different types of hobbies, right? A person, well, not even hobbies, different, some people will smoke, some people will drink, some will do drugs, some will do all three, some people do none, okay? And, and so we have all different type of people throughout the world. But what we tend to do is we use a reference range, okay? And the reference range was a 22-year-old man, 154 pounds, light physical activity, consume 2,800 calories a day. The woman is the same as a man, except 128 pounds and 2,000 calories a day. So given that the blood pressure, heart rate, hormones, and is different, given numbers for any physiological factor point to 95% of the population, and you must keep in mind that 5% would have the numbers that vary from these textbook values or are still normal. Now, everybody says, what's the normal blood pressure to me? Well, 95% of the time, 95% of the time, 120 over 80 is the normal blood pressure. You have blood pressures that are a little bit higher. You have blood pressures that are lower. There are many people. My wife, for example, has a low blood pressure. Doesn't mean that it's hurting her, but that's what it is. She'll run about 90 over 70. And for her, that's normal. If I had 90 over 70, I'd be, on the floor calling 911. So everybody's different. Okay. But up to a certain degree is blood pressure normal. After a certain point, we say it's high blood pressure, and that's not. So what are some characteristics that describe living things? They all exhibit complex organization and order. They all engage in metabolism, the sum of all chemical reactions that occur within the body, right? So you have and it's composed of anabolism and catabolism. Anabolism, small molecules joined together to form larger ones. Catabolism, um, larger molecules are broken down into smaller ones. And they all grow and develop, right? You increase in size is hypertrophy. When you increase in cell number is hyperplasia. Okay, you can specialize or differentiate in the cells. You can assimilate materials from the environment. Okay, and development does not stop until adulthood. Yes, Jonathan. Okay. So, anabolism. Two small molecules come together to form large, like oxygen and hydrogen give you water. Okay, but you have carbon phosphorus, oxygen, hydrogen, nitrogen, and sulfur. We'll put them together in a certain way, you'll get DNA molecules. Metabolism, you break down larger molecules. So what physiological process or what human process breaks down larger molecules into smaller?
Digestion.
Digestion, right? And you assimilate materials from the environment. Has anybody ever heard you are what you eat?
Yeah.
Yeah.
Yes.
Yes.
You are what you eat. If you ate the chicken, well, guess what? That's the chicken that your body breaks it down. You take this protein and you have now chicken protein becoming your protein. You are what you eat. That's exactly what it is. Right, so the cellular level consists of cells, the smallest living structure, the basic units, and the structures and functions of the organism. All living things exhibit responsiveness, the ability to sense and react to stimuli. Okay, a hot stimulus to the hand causes a person to withdraw. All exhibit regulation, adjusting internal body function to environmental changes. Homeostasis, the ability of an organism to maintain a consistent environment, right? So you run, you exercise, you sweat because you get hot. As you sweat, you cool down. Okay, when you cool down, you go back, you're cooling down, so you get too hot, you cool down, you go back to 98. What do you think? Should I let him in? The two people waiting in the waiting room. Should I let him in?
Yeah, let him in.
Sure?
Yeah. Yes.
Sure? You sure?
Yes.
Let him in.
The first day.
Let him in.
It's their first day. Let him in. I'm admitting them. Come in. I know why they admit it. Jonathan, you have a question? Jonathan Menasco.
My apologies. No, no question.
Is that a dog in your picture? What is that? I can't say. I don't know what that was. Anyway, and all living things reproduce. They produce new cells for growth, maintenance, and repair. You cut yourself, and the skin will reproduce to put it back. And you also have sex cells that can develop into new organisms.
I love the background now.
Catherine Huertas, Stavros, you just came in. You gotta mute yourself. Homeostasis, hundreds of anatomic structures and physiological processes are continuously monitored. Homeostasis is the body's ability to maintain a stable internal environment in response to changing conditions. You have a set point, much like a thermostat. The set point will show you the body temperature, right? Your body temperature 36.7 to 37.2. Or blood glucose is 80 to 120, where blood pressure 90 to 120 over 60 to 80. So these are all ranges that your body needs to keep in check. Okay, so any deviation from those ranges, your body needs to fix. You have a fever, your body's you're running, you're sweating, you're getting hot, you'll sweat to cool back down. Your blood glucose goes down to like 60 because you haven't eaten. Your body will send out glucagon so it can break down stored sugars in your system to pump it back. Okay. If you haven't drank enough water, your pressure is low, your vascular system will constrict to make the blood pressure go up. So those things that you hear, those are stimuli, right? You get too warm, that's a stimuli. Your blood glucose too low, that's a stimuli. These are all different variables. Okay, it's a deviation from that set point, which causes that to occur. So you have that feedback system, negative and or positive. The negative, basically how this works is you have three components to it. You have the receptor, the sensory set receptors, all right, that that will sense a stimulus. You have a control center that interprets the information from the uh, stimuli or the receptor, and then you have an effector, a muscle or gland that will basically adjust or carry out the control center's basically demands or wishes, what have you. So negative feedback, okay, result is a resulting action in the opposite direction of the stimulus. So for instance, just like a thermostat, if it's too hot and you have it at 60 degrees for the AC, right? As the temperature goes above 60 or hits 65, then the thermostat turns on and brings it back down. Okay, it controls most processes in the body. Thermal regulation is the biggest one that we always talk about, right? Heart rate, blood pressure is another one during exercise, and also parathyroid hormone response. So, for instance, when you are running, you get hot, you vasodilate. Vasodilate means that your vessels basically get larger. You sweat. The hair follicles flatten. Okay, they stretch out to increase the surface area, to increase the heat loss. When it's cold, your blood vessels will constrict, they get smaller. Okay, you'll shiver, the hair stand on end. Okay, makes yourself smaller for a smaller surface area. All right, let's see. Okay, so that's negative feedback. Positive feedback, however, is a completely different thing. Positive feedback only rarely occurs in a couple of areas. And the only one of the areas that we always talk about is childbirth. Okay? Positive feedback is the amplification of a response to a stimulus. For example, in childbirth, when the head of the fetus pushes against the cervix, it stimulates nerve impulses from the cervix to the brain. The brain is notified, it signals the pituitary gland to release more oxytocin. Oxytocin is then carried via the bloodstream to the uterus, causing contractions, pushing the fetus towards the cervix, eventually inducing. So breastfeeding, urinary contractions, the clotting cascade that you have, and believe it or not, even human orgasms are all part of positive feedback. Okay, so what are some of the summaries and the of homeostatic system characteristics? They're dynamic. They're regulated through negative feedback. 99% of them are. They have a receptor, control center, and an effector. Okay, the control center is usually the nervous system or the endocrine, and it is when these systems fail that a homeostatic imbalance occurs. Diabetes is an example of a homeostatic imbalance, right? Because there is a problem in metabolizing blood or regulating blood sugar. So diabetes causes blood sugar to go up, and you don't have enough insulin, so therefore there is a problem with homeostasis. Okay. What we do as doctors is we treat a patient. Treating patients involves finding a diagnosis, a specific cause of the homeostatic imbalance. And most medications we have side effects we have to look into. A lot of patients tell me, well, what are the side effects of these things? And I go over it with them. So these are the side effects you're going to be taking. However, if you don't take it, you're going to bear the brunt of having problem with your homeostasis. Okay, so you have things like SSRIs, are drugs that regulate the reuptake of serotonin in nerves and cells for depression. So these these will decrease their reuptake inhibitors. Okay, so, these reuptake inhibitors block serotonin from being taken up. Therefore, the serotonin breaks the brain, and the person is happier for it and less depressed. Let's do something. Let's take a 10-minute break. Okay. As you guys stretch a little bit, it's what time already? It's about an hour. But we're gonna take a 10-minute break. Be back in about 7:40.
Sounds good.